Hello and welcome back to the last tutorial, sentiment analysis. Sentiment analysis is a power tool that allows computer to understand the tone of a text, a piece of text, or sentences. In this tutorial, we will learn how to use machine learning to determine the sentiment of the text, how to use the SPACY to build an NLP pipeline that fits into a sentiment analysis classifier. We first install a library which is non-keyword, which is not installed in Google Colab as a default. We import all the libraries that we need, functions, and then we already talked about most of them, but here that for the evaluation we use a classification report, confusion metrics, and accuracies. We read from CSV file, and then this CSV file is available here, and which is related to the data set in FINML1EN sentiment, so you can find a connection here. We put it in Google Drive and we download it, and then we read it using data frame. So we read CSV and put it as a data frame. These are the first 5 rows of that data frame. You can see that we have a column, a sentence, we have a sentiment, and then the number that is related to the sentiment of that sentences is 0 if it's neutral, if it's negative it's -1, and if positive is 1. We can see here the distribution of our data. Most of the data that we have are neutral, and then positive, and then after that negative. Negative is a low portion of that data. And here we want to learn that how you can create a pipeline in natural language processing, the one that we explained in the first tutorial in this section. So we want to just go step by step. We create a model, we evaluate it, and so on. And so the first step, as you remember, is related to processing and also normalization. And the normalization that we consider here is stemming. And for that one, so we start with removing punctuation numbers and special characters, and we put all these in separate column as a clean sentences. And then after that, we use the stemming and then remove stop words. You see here that we had with the new and then here is disappeared, and here that you see that we have some clean sentences, and then here we have the stemming version of that. We have some positive, negative, and neutral. One way to analyze better is to see the distribution of the words for the words inside these sentences. So we put one example for you to see these words, and one way that we can see it is a word cloud that you can actually install it and then have it here. What is already installed in Google Colab, and then you can see, you know, the number of the words that is related to the positive, because here we set out, put all the words positive from the data frame that we had. If the number of sentiment is equal to 1, and only take the value from the column stem sentence, and I use it to tokenize these words, and then put it here all words positive, and then have the cloud version of the words, and 2 here is like the biggest word, and it means that it has the highest frequency, and after that is 1000. So you see here that is the words that's related to positive is mostly numbers: 5 million euro, 100, increase, 30, so it's 40, So these are mostly numbers, so you can have an idea that what's going on related to the positive. We put it here that it's just for you as an example that you can have more idea about the words. So now we want to represent the text in numerical form, or we talked about it as embedding. One thing that we want to do is using TF-IDF. So we already vectorized using TF-IDF from the scalar module, and then we divide our vectorize from the list of the sentences in the stem columns, and then here using train test split, we actually set the test size as 0.2, which means that is 20% of the data is test, and then 80% is training data set. For training the model, another step in our NLP pipeline is for that one, we want to use random forest classifier because it's a classification problem. We have three classes, is neutral, negative, and positive. We set some parameters for that you can change it. You can have different result, and then logistic regression again. We feed it, we train it, and then we set C as 0.5. Another step, we want to evaluate our model. And for evaluation, we need to put it here differently because that belongs to evaluation. And here a text classifier for random forest, a text classifier for prediction of text classifier for logistic regression. And then here we want to see the performance using confusion metrics, accuracy score, and also classification report that we report precision, we call F1 score. We already talked about this, that what is this value? You see here that the accuracy is 73% for random fires, but for logistic regression we have 74%. We have different results for some of them. And then another thing that we want to do, another vectorization, and this is counter vectorization, back of words. We want to see how the result is different if we use back of words. For logistic regression, we set different values to see which one has the better accuracy, and then we can see here that this value is is better, and then so we can set it as 25 and then compute it on that. And here see what is logistic regression. We have 76% accuracy, which is higher than the previous one using counter vectorizer. We can do the same thing here. Let's see if we put 0.25 here. And then here, you see here we have 76% again. So if you want to compare fairly, it's almost the same using TF-IDF with back of words, because as you know, these models are based on the frequency of words. It's not that much difference, but you can use different embedding to see how the result is changed, because we already do that for information retrieval. We don't want to use it here, but as an assignment, you can try to do that. And we do again on the counter vectorizer, and then here that we create something that we can do differently here, that we set binary as a false. And then we did this as like before as binary true, so we want to see the changes. Something that is different when the binary is false is something that is as a default, and the vectorizer is based on the frequency of the word, but its binary is true. The vectorizer is based on that if the word is exist in the text or not, so it's only 0 and 1, but here is based on the frequency. So we do this binary false, and then to see how the result is different, and then we predict. We use the same rate, and then we check the result with almost the same. Let's see here, there's nothing changed. This is an option that you can do. We use another model is SVC. Is this support vector classifier, which is linear. So we set the parameter C over there, and then again we evaluate the model. Let's see, doing same C here, and then we predict it. We see here that we have 75%. We also use LSTM because we didn't describe LSTM in our slides, so I don't go through it, but I put it here for you to have an idea that if you want to use LSTM and then create a model, how you can do that for the sentiment analysis. You can train it, and then at the end you can evaluate it. For the assignment, compare the performance of BERT and FINBERT. So use BERT for vectorization, and then after that fine tuning on the text data, and then to see it and compute the performance of that model. And also use FINBERT. That is, you have the model, you have the classifier, you have everything, you have the code here, and then you can have access, and then you see that how you can improve. Of course, you can improve it, try it. You can improve the accuracy by using BERT and FINBERT specifically, which is trained on the financial data, and more specifically annual reports. And then compare the performance. Thank you so much. This is the last one. Hope you enjoy this tutorial.